Now in this example, we want to find the flux across the surface of the cube, defined by the absolute value of x is less than or equal to 1, the absolute value of y is less than or equal to 1, and the absolute value of z is less than or equal to 1 for this vector field. Now remember what this means. This would mean that -1 is less than or equal to x, which is less than or equal to 1. Same with y, same with z, right? So this is a cube that's really of length 2 on each side. Oh, that's 1. -1 is less than or equal to z, which is less than or equal to 1. Okay, so if we think about a cube, this particular cube would be of length 2 on each side, but it would have the axes kind of poking out of the middle, right? So you're going to have your y-axis here, you're going to have your z-axis here, you're going to have your x-axis coming out this way, right? Because there's a central point inside that cube. Now, we do not want to do the surface integral method because the surface integral, so let's make a note here. The surface integral method for finding flux would require us to find 6 different separate integrals, separate double integrals. There, so the double integrals. So yuck. So we will use the divergence theorem. And we can use it because it's a closed surface. Right? Because the surface is closed, we can use the divergence theorem. And that's what we will do. All right. Now, what is the divergence theorem? The divergence theorem says, and I'll write it down here, I'm going to leave us some space, but the divergence theorem says that divergence is equal to the triple integral over the solid of the divergence of f dv. Okay, so to do that, we're going to need to find the divergence of f. All right, well, let's go find that. So f was written right up here, so I'm not going to rewrite that. The divergence of f is equal to the del operator dot product with that vector field. So that'd be delta delta x, delta delta y, delta delta z, dot product with x plus z, x plus y squared, y plus 2z. All right, so the derivative with respect to x of this first piece is 1 plus, right, because this is a dot product, we're going to have a scalar here. So 1 plus the derivative of the middle piece with respect to y would be 2y, plus the derivative of the back part with respect to z would be 2. So this whole thing becomes 2y plus 3. That's the divergence of f. Wonderful. All right, so now for our integral, we're just going to put in 2y plus 3. All right, now this is classic rectangular coordinates. We don't have to switch this into polar or cylindrical or spherical. We can leave this rectangular, right? Those are the 3 coordinate systems we have for 3-dimensional objects. Rectangular, cylindrical, and spherical. So because, I'll make a note, because this is a cube, right? Because surface is a cube as opposed to a sphere, we will use rectangular coordinates. They'll be easier. Okay, so we're going to go dz dx dy or dz dy dx. It doesn't really make any difference. dz d. Well, I see that y is the variable in here, so I'm going to wait and do dx next and dy last because y is the only variable I actually have. And then these are all going from -1 to 1, -1 to 1, -1 to 1 because it was given to us as a cube. All right, now let's think about this for a second. This doesn't have a z in it. So when we integrate with respect to z, it's going to have 2y plus 3 times z, but z goes from -1 to 1. Here, -1 to 1 dx dy. Okay, so that's going to be 1 take away -1, right, when we substitute in. And 1 take away -1 would be 2. And the same thing's going to happen with x. There's no x in this. It's very similar to what we've been doing throughout the course when we take the 2 pi out, because it's 2 pi minus 0 for theta. When we do x, there's no x in here. So when we integrate with respect to that, here, let me write this out. So this is negative 1 to 1, negative 1 to 1, and now we're just going to multiply the whole thing by 2, and it's 2y plus 3 dx dy. But what I'm saying is, hey, we know that this piece is also going to be 1 take away negative 1 when we integrate it. So let's just make it 2, and let's stick another 2 out in front. 2 times 2, and then we're going to integrate from negative 1 to 1 of 2y plus 3 dy. Well, that's 4 times, the integral of this would be y squared plus 3y from negative 1 to 1. And that would be 4 times, okay, so when I put 1 in, that's 1 plus 3, take away. When I put negative 1 in, that's negative 1 squared. Negative 1 squared is 1, minus 3. Okay, so this is 4 times 4 take away a negative 2. So that's 4 times 6, which is 24. And we're done. See how wonderful the divergence theorem can be when it all works out beautifully. Just keep in mind, the brute force surface integral method probably wouldn't have been super hard, but you would have had to do 6 different setups to set it up correctly. Right? This way, with the divergence theorem, just needs one correct setup with the triple integral right here. Right? This setup right here. As long as you can set that up, then the integration worked out nice and easy.